Alright, this video is about section 9-2, which is on reflections. Reflections of figures over a line, and also specifically reflections of figures over a line in the coordinate plane. Okay? By the end of this video, you should be able to identify and describe a reflection, and also be able to reflect a geometric object in the coordinate plane when given a line. Okay, before I give you the formal definition from the textbook, let me give you a couple of examples using Geometry Sketchpad. Okay, so here we have triangle ABC on your left, and I've reflected it across the line in the middle, and you get triangle A prime, B prime, C prime. Now as I move the triangle, you'll see that they both change because it's a reflection. Okay, I can also adjust my line so it's not vertical. It can be any line, and it's reflected. Now I think a lot of us just understand a reflection, that it's a reflection. That's an easy idea. Okay, now the definition is a little abstract, I think, but a reflection across line R, called the line of reflection, now it's not always called line R, but it's always the line of reflection, is a transformation with these two properties. One, if point A is on the line of reflection, then the image of A is itself, meaning once you reflect it over that line, it stays the same point. Okay? If point B is not on line R, then R is the perpendicular bisector of BB prime. Okay, which doesn't really make a lot of sense, but if you think about the fact that the distance between a point and the line is the perpendicular distance, meaning the distance from B to line R is this distance. That's perpendicular, and the distance of B prime to the line is also perpendicular. And since it's a reflection, these two lengths are the same, we would call it a perpendicular bisector. Okay? And also keep in mind that a reflection across a line is an isometry. Okay, let's look at some more Geometry Sketchpad files. Okay, we've seen this one. Okay, now in the coordinate plane, this red line, which is also the y-axis, is our line of reflection. Okay, it happens to be vertical at this moment, but it doesn't always stay vertical. Okay, now A and A prime are both graphed for us, so the point A is at 4, 2 right now, and A prime across the y-axis is negative 4, 2. Now an easy way of seeing that is that from A, we're going to go perpendicular to our line of reflection. Okay, and the distance that A is from the line of reflection is 4 units. So if I keep going 4 more units, I'm at A prime. Okay. Let's try changing let's just try changing the line of reflection. Instead of being vertical, let's have it be horizontal. Okay. Again, we will look at the length that's perpendicular to the line of reflection. Okay. Now we are 3 units away from the line of reflection, so I'll keep going across that line perpendicular to that line 3 more units. Okay, and I have A prime. Okay, keeping that in mind, let's review quickly vertical and horizontal lines, at least the equations of which. Okay, the line, this horizontal line, is defined by the fact that every point on the line has a y value of 2. Okay? So no matter how far we go over an x, we will always go up 2 units. Okay? And so this line is y equals 2, which can be a little counterintuitive because it's kind of parallel to the x-axis, and so we kind of may want to call it x, but the point is the fact that it always has the same y value, and so the line is y equals 2. Okay. Similarly, if we're down here, for example, again the y value is always the same, and that y value is negative 3. So the equation of this line is y equals negative 3. Okay. Now you may guess that lines that are vertical then, like this one, the x values now are always the same. The x values are always negative 1. So no matter if I go over negative 1, up or down, no matter how far I go up and down, I always have an x value of negative 1. So this equation is x equals negative 1. Or if I'm over here, my x value is always going to be the same, and it's going to be x equals 5. Okay? So in general, horizontal lines are y equals something, and vertical lines are x equals something. Okay, so if point 3, 4 is reflected across the line y equals 1, what are the coordinates of its reflection? It's a multiple choice question. So I'm first going to plot the point 3, 4. So from the origin, I go 3 in the x direction, 1, 2, 3, and I'm right here. And then I go up 4 in the y direction, 1, 2, 3, 4. So my point 3, 4 is right here. Okay, the line y equals 1. Now y equals is going to be a horizontal line where y is always equal to 1. Okay, now again I'm looking at lines that are perpendicular to the line of reflection. So I'm looking at this distance right here. And that distance happens to be 3. So I'll keep going across that line perpendicular to the line of reflection 3 more units. And I'm right here. The coordinates of that point from the origin, I go over 3, and now I'm going down negative 2. Now I'm going from the origin over 3 down 2. I know it's kind of easy to use kind of from the line of reflection, but you're looking at it from the origin. You go over 3 down 2, and so the line, the image of this point is 3, negative 2. Okay? Now, before we jump into graphing a figure like a triangle, let me show you again what it looks like in Geometry Sketchpad. Okay, here's a triangle ABC, and triangle A prime, B prime, C prime, and I've also included the coordinates. Okay? Now we can move it around. It says a reflection, which I'm not surprised about. Now one thing to notice is that when the line is the y-axis, the image happens to be the same coordinates as the pre-image, except the x-coordinates are negative. Okay. Similarly, if we have our line of reflection be the x-axis, okay, it's a little confusing because they're overlapping. Let's go like this. Okay, if we have it be the x-axis, again you have the same coordinates, but now the y-coordinates are now negative. Okay, but again we're still keeping the same distance across the line of reflection that's perpendicular to our line of reflection. All right, so if A is negative 3, 4, I'll just plot that point. Okay, that's A. And B is 1, 0. I'm sorry, 0, 1. And point C is 4, 2. Okay, our triangle looks like this. Okay. What is the image of ABC reflected across the y-axis? Okay, the y-axis is right here. So that goes up and down. Okay, now start with point A. Point A, going perpendicular to the line of reflection, I've gone 3 units. So I keep going 3 more units. And this point right here is A prime. Okay, point B is on the line of reflection. So if I reflect it across, I get the exact same point. So this is also B prime. Okay, C is, I'll go perpendicular to the line of reflection, and I go 4 units. So I go 4 more units, and I get C prime. Okay, now there are lots of lines. Sorry about that, but if I draw this, okay, let me just, anyway. So the black triangle, triangle A prime, B prime, C prime, is the reflection of triangle A, B, C. I know it looks a little crazy because I have the other lines in there, but hopefully you get the idea. Okay, some last questions. What are the coordinates of H across the y-axis? I'm going to draw in the y-axis just so I can see it better. And perpendicular to the line of reflection, I go over 1, 2, 3, 4, and go over 4 more units. 1, 2, 3, 4. It's right here. The coordinates of that point are negative 1, 2, 3, 4. And I go down 1, 2, 3. Okay? So the coordinates of that point are negative 4, negative 3. Okay? Number 2, what are the coordinates of G reflected across x equals 3? So the line of reflection now is x equals 3. Okay, now G is right here. I'm going to go perpendicular to the line of reflection. I go over 1, and then 1 more. And this is G prime right here. So the coordinates of G prime are 1, 2, 3, 4. And I go up 1, 2. Okay, so these are the coordinates of G prime. Okay, graph triangle FGH and its reflection across y equals 4. Now since that will kind of go off my grid, and we've done a couple examples like that, I won't do that one in this video. Alright, so for a challenge problem that shows up on the homework, we have the line not be just horizontal and vertical, but a line that's diagonal. Okay, a line that's either y equals x or y equals negative x. Okay, now again, we are still going perpendicular to the line of reflection. So if our line is y equals negative x, which is currently the dark red line, we'll still go perpendicular. So from point A, and the way I do this is if it's y equals negative x, then I go perpendicular, go the other way, and I count the number of diagonals. So it's 1, 2, 3.5 diagonals, and I go a half, 2, 1, 2, 3, 3.5 diagonals, and I get A prime. I hope that kind of makes sense. Okay, if I move the point around, okay, if I move A, okay, here it's going to be from the diagonal, it's 1, 2, 3 diagonals, and I keep going 1, 2, 3 more diagonals. Okay, now the same is also true if we have our line be y equals x instead of y equals negative x. Okay, I'm still counting the number of diagonals and going now, and that's still perpendicular. Okay, that's kind of a heads up for some of the challenging questions on the homework. Okay, this video was an overview of section 9-2 on reflections, reflections of figures over a line, and also specifically reflections of figures over a line in the coordinate plane. Okay, hopefully you can identify and describe a reflection now and reflect a geometric figure in the coordinate plane.